Hello everyone, my name is Ashrit from CSC AIML A section. So today I'm going to talk about the topic of for the tech talk is nanotechnology for optical networks, a revolution in communication. So we're going to talk about how like the transformative impact of nanotechnology in the future of optical networks. It's like today we're going to talk about the highlights of the intersection of advanced materials like material sciences and communication technology, the crossover between them. So we're gonna go and talk about how nanotechnology affects the communication between us. So the promising future of micro nano optics, shrinking the future. So till now we've talked about big materials and doing big things in infrastructure as such. But while it comes down to communication, we're gonna have to go smaller, more minute, more miniature. So now we're going to talk about the miniaturization. Nanotechnology enables the creation of smaller yet more efficient optical components, paving the way for new generation devices. So nanotechnology mainly involves like manipulating matter at an atomic or a molecular scale to create newer materials and devices with enhanced properties, with better properties. So yeah. The higher bandwidth is another promising feature. So the higher optical fibers and photonic crystals lead to a higher bandwidth, enabling faster data transmission and more reliable connections are made. So in optical networks, which forms the backbone of modern like communication systems, nanotechnology can lead to more significant improvement in data transmission speed and efficiency. While coming to efficiency again, the energy efficiency. Smaller components require less energy to operate, creating more sustainable and energy efficient optical networks. So, nanomaterials, when we talk about them, like 2D materials that are like leading the way, how like this 2D materials or the single thin layer materials will have like help in communication. Let's talk about nanomaterials as such. So, graphene, a single layer of carbon atoms with exceptional conductivity and optical properties, like perfect for high speed optical communication. So graphene and other 2D like materials, these materials have unique optical and electronical properties which have can leverage to create ultra fast and energy efficient communication devices. Then molybdenum disulfide, another 2D material with unique optical and electrical properties, offering potential in optical modulation and sensing applications. Then again, there is tungsten sulfide, another promising 2D material with potential for use in optical signaling processing and enhancing data transmission efficiency. So like, and others can also quantum dots. Like these are nanoscale like semiconductor particles can be used to create high efficiency like light sources and direct detectors, improving the performance of optical systems as such. So then there's also nanophotonic devices. Like these devices are just nano lasers or photonic crystals can manipulate light at a nano scale, like a small, minute scale, leading to more compact, efficient creations of communication devices and equipment. So, enhanced optical fiber nanoparticles for speedier performance. So, improved transmission. These nanoparticles, uh, like embedded in optical fiber system, can help enhance light transmission, reducing signal loss and increasing data capacity. So, uh, like with the help of these like improved transmission in the sense nanoparticles can help you the reduce the loss between jump of signal to signal, reduce the signal loss between them. So increased bandwidth of these fibers can handle higher data rates and enabling faster and more reliable communication networks. So more data rates accommodating the growth of demand for data byte than bandwidth as such can be done using nanoparticles and greater flexibility. Like when we talk about nanoparticles, it can be used to modify the fiber's properties, making it more flexible and adaptable to diverse network configurations. So, as it is more miniature, the use of nanoparticles allows for development of smaller and more compact devices It can also be used to enhance or like change or alter, modify the properties of the fiber. Let's talk about photonic crystals, trapping light by for breakthrough applications. Photonic crystals are important like devices as well. So light manipulation. Photonic crystals control light propagation, enabling the creation of optical filters, waveguides, and other devices and components. Optical switching. These crystals can be used for like to create fast optical switches, like essentially for data efficiency or routing and network management. Optical computing. So photonic crystals hold potential for developing next generation of optical computers with unprecedented processing speeds and efficiency. As such, when you talk about photonic crystals, are going to help increase or take optical fibers to a whole new level. Because with this, you'll be able to add more optical computing capabilities to these things. Let's talk about applications. So applications for nanoparticles as such you can use for sensing, filtering, and networking are like the main 3 points we talk about right now here. So optical sensing. Nanotechnology enables sensors uh, can detect a wide range of parameters from temperature to pressure to chemical composition and biological markers as well. So it makes them more smarter and more efficient. Optical filtering, when you talk about photonic crystals I've discussed previously, can act as like highly precise filters and like set specific wavelengths of light for various applications. So we'll talk about optical networking as well, like connecting with each other. Nanotechnology-based optical components enable the creation of faster, more efficient, and scalable optical networks. So these are like the current or the more usable cases of what is possible and such. So when we talk about the advancement, the big advancement of optical communication networks. So what are when we talk about the improvements nanotechnologies has done for specifically when you talk about optical fibers and cables and as such. So because of nanoparticles, optical fibers have been enhanced. How it is improved in the transmission, boosting of bandwidth, the energy efficiency. It is also able to modify the already existing properties of the fiber to make it more flexible. So next one we could talk about is the photonic crystals. Advanced optical components and components like which help them um, faster switching and filtering. So photonic crystals are a big help when you talk about optical fibers as such. And photonic crystals also help in creating filters and routing data that like is necessary and essential for like conversation and as such. So photonic crystals I've previously discussed are like an important and a big part while talking about transmission. So like there are nanostructured materials designed to control and manipulate the flow of light. So they are like characterized by periodic variation in their refractive index, like how crystal is. It creates a photonic band gap, a range of wavelengths which is from the forbidden from propagating through the material. Like it only selects a certain amount of thing to pass through. So the photonic band gap is analogous to the electrical band gap in semiconductors. It's similar, just preventing a certain energy level below to not pass through. This can be used for creating highly effective, efficient mirrors and waveguides and filters. So applications we can talk about is optical fibers, talked about right now. And then in telecommunication, sensing and medical applications as well. Then I can come to 2D devices like graphene and other things, which are like materials that use increase the possibilities as well. So while we talk about the future of nano, like the key takeaways and what like the possible next steps could be, we can talk about, right? Is we should talk about the challenges as well. Nanoparticle is poised to revolutionize like the optical networks, enabling faster and more efficient, more sustainable communication. So future research will focus on scaling up these technologies as well, new nanomaterials. So manufacturing scalability will be an important task. Integration of existing infrastructure to again lay new optical fiber cables as well to change. So continuous research in R&D as well. So in summary, we can talk about nanotechnology holds like a large promise for revolutionizing optical networks by enhancing the performances, efficiency, scalability, bandwidths as well. So this can lead to a transformational change in how we communicate when paving the way for new generation communication devices and technologies. So with this, I'd like to conclude. Thank you.